do a quick review of multiplying and dividing terms with exponents. In this problem we have a squared times a to the fifth over a. Whenever we're multiplying two variables with exponents, we add the exponents. So I'm going to work with the numerator first here. We have a 2 and a 5 in the exponents, so we're going to add those together to get a to the 7th, and our denominator remains unchanged. And now when we divide, here we have a to the 7th over a, we take that 7 and subtract it from this invisible 1 here, and we're going to end up with a to the 7 minus 1, or a to the 6th, in our numerator. So that's a basic example to get started. Now this one's a much messier one. We have a power of a power, we have negative powers. First thing you want to do with these types of equations is get rid of the powers of powers. So let's do our order of operations. And we have an x to the 1/3 all to the 2nd power. So if we multiply that out, we're going to get x to the 2/3. I'm going to leave everything else unchanged for now. So now we have no more powers of powers, and we need to get rid of our negatives. Now there's lots of different correct ways to solve this. I like to get rid of my negatives right away, so let's go ahead and do that. Something to the negative 2 power and negative 3 power. We switch that to the other side of the fraction. So I'm going to move that y to the negative 3rd up top as y to the 3rd. Take my x to the negative 2nd, move it down as an x squared. In the next step, I want to combine like terms in my numerator and like terms in my denominator. So nothing to do in my numerator, but in my denominator I can take that x and x squared and make it x cubed. And then finally I see I have an x term on top and an x term on bottom, so I'd subtract my exponents and I would get something like y cubed over 4x to the 7/3. However, if I do that, I have a fractional exponent in my denominator, and we know that mathematicians don't like to do that. So the closest whole number is actually going to end up looking like this problem here, x to the 2/3 over x to the 3rd, and you don't want to do what I just did and simplify that last step. If you had something more than 1 in this exponent, such as x to the 4/3 over x to the 3rd, you could pull out a full x from the numerator and denominator, but we don't have that here. So this is where we stop.